There was a time when the world lived under constant tension. Two superpowers, each holding weapons capable of ending civilization in a single afternoon, watched one another across an invisible line. The exact year mattered less than the atmosphere. Deep inside reinforced rooms of concrete and steel, people sat near control panels they hoped would never be used. This was the Cold War, not a conflict of open battles, but a war of preparation, calculation, and anticipation, where staying one step ahead of the other side could mean survival. By the late 1950s, military planning had reached a level of complexity no human mind could fully manage. Thousands of aircraft, missile sites spread across continents, submarines moving unseen beneath the ocean, radar stations scanning vast skies, and opposing forces doing the same. Weather, communication delays, response times, and the narrow window between decision and consequence all had to be considered at once. A single miscalculation could cost a city. A delayed response could cost a nation. The mathematics of modern warfare had moved faster than human capability, and something had to change. The solution being discussed was both simple and unsettling. What if a machine could track everything at once? What if it could process information faster than any team of analysts, calculating outcomes in seconds instead of hours? This was not imagined as science fiction, but as necessity. Engineers and planners envisioned a system that could absorb data from radar stations, intelligence reports, and sensors across the globe, building a real-time picture of the world as it existed in that exact moment. The goal was not to replace commanders, but to support them by presenting clear options when time mattered most. So they built it, not a single computer, but entire networks of them, rooms filled with cabinets of electronics, miles of wiring, and systems that consumed enormous amounts of power. These machines required constant maintenance and teams of specialists to keep them running, yet they worked. They could track objects in the sky, model potential attacks, calculate trajectories, estimate damage, and suggest responses. For the first time, machines were directly involved in decisions related to war and peace. What mattered most, however, was what these systems were never allowed to do. They were not given authority. They had no power to act on their own. Every recommendation still required a human decision. The machines could calculate probabilities with incredible speed, but they could not understand context, restraint, or consequence. Those responsibilities remained with people who understood that protecting a nation sometimes meant choosing not to act. Even so, a difficult question remained: how much trust should be placed in the machine? When warning indicators appeared, when the system reported a threat, and when time allowed no second opinion, the balance between trust and caution became critical. Too little trust made the system ineffective. Too much trust made it dangerous. This was not a technical challenge, but a human one, unfolding under the highest possible stakes. The world was never handed over to the machine, partly because the technology still had limits, and partly because those who built and operated it understood something essential. Judgment cannot be automated. A computer can calculate what is likely. It cannot determine what is right. There were documented moments when operators chose to ignore the system's conclusions, guided instead by experience and intuition, and those decisions proved correct. That restraint was intentional, built into the system from the beginning. That computer did not run the world, but it changed it. The technologies developed for those networks evolved into systems used for weather prediction, communications, logistics, and planning. The methods designed to track threats became tools for managing complexity across modern society. The influence of those decisions extends far beyond the Cold War itself. At a moment when technology offered speed and certainty, the people in control chose caution. They kept human judgment at the center, accepting slower decisions in exchange for wiser ones. That choice required humility, and in an era of existential risk, it may have made all the difference. The Cold War ended not through automation, but through careful decisions supported by machines and made by people. The computer that almost ran the world now belongs to history, but the question it raised remains: when we build systems of immense power, how much control should we give them? The answer then and now is the same. We use machines to extend our abilities, but the final decision, the one that carries meaning and consequence, must remain human.